Welcome, welcome back to the current session of operating system. Dear friends, in our previous sessions we have learned about the concept thread, and we have also understood the advantages of using the thread concept, in which we have seen certain advantages, and we have also seen the difference between a multiprocessing and a multi-thread environment. So today in this class we are going to see various thread architectures or thread models, and we are also going to see the operating systems where this multi-threading is going to be implemented. See friends, our discussion in our previous classes about the threads are mostly they went in a general scenario or in a generic sense, but the support for threads may be provided either at the user level. Normally we call them as the user threads, or some threads have been running at the kernel level, so they are called as the kernel threads. So that means the threads which are running at the user level, that means if there is no intervention for the operating system, and if the thread is going on, then you can call it as the user thread. If the threads are being executed under the supervision by the operating system, then you have to call it as the kernel thread. So user threads are supported above the kernel and are managed without the kernel support, whereas kernel threads are supported and managed directly by the operating system or kernel. So in the today's world, that means all the contemporary operating systems like the Windows operating system, Linux, Mac operating system, Solaris, and you can have the latest version, that is Unix, true 64-bit Unix. So formally it is called as the digital Unix. So all these operating systems, they support kernel threads. So ultimately a relationship must exist between the user threads and kernel threads, correct or not? So if user threads and kernel threads, they are independently executing, then we cannot get a meaningful way, or it is not of good sense. So there should be a switching, there should be a communication between, there should be a connection between, or relationship between user level threads and kernel level threads. So we are going to see about these kind of threads. Friends, such a relationship has been developed or designed in three models. Such a relationship has been designed taking the strategies of three models. The first model is the many-to-one model, and the second model is the one-to-one model, and the third model is many-to-many model. So these three models indicate the relationship between user level threads and the kernel threads. Let's try to understand the many-to-one model. See, the many-to-one model, as shown in the picture, it is a mapping between many user level threads to one kernel thread. I think you got my answer. See, many-to-one means you have many user level threads and you have one kernel thread. So many user level threads are being mapped to a single kernel thread. That means all these many user level threads are being running within the user context, and there is no supervision of the operating system. Whereas all these user level threads are being related to a single job which is under the supervision of the kernel thread. I think you got my point. So the thread management is done by the thread library in user space. So it is efficient, but the entire process will block if a thread makes a blocking system call. I think you got a little bit more detail here. So what does it mean? It means that even the kernel thread which is executing and which has been mapped with many user level threads, So if single kernel thread has been made into a block, then that block system call will block all the user level threads, because all the user level threads has been mapped to a single kernel level thread. We should also know that because of only one thread is going to access the kernel at any instance, even though there are many threads which are mapped onto the kernel thread, there are many user level threads mapped onto a kernel level thread, okay, but at any instance only one user level thread can access to the kernel level thread. So what does it happens? It happens that, so even though you have many user level threads, but at any instance only one kernel level thread has been accessed by the user level thread. So this leaves something like the multiple threads are unable to run in parallel on multiprocessors. You have to remember this statement. So in such a case, multiple threads or multiple user level threads are unable to run in parallel on multiprocess because they are all being mapped to a single level kernel thread, right? So that means green threads, a thread library available for Solaris uses such a kind of model that is called the many-to-one model, as does the GNU portable threads. So in Solaris, this kind of model, what is the model here? The many-to-one model is going to be implemented in the Solaris operating system. So you may get a question something like in a reverse order. So what might be the threaded model, or what might be the multi-threading model in Solaris? So the answer is straight away. In Solaris, it is going to be implemented with the many-to-one model, in which many user level threads are being mapped to a single kernel level thread. Let's move to the second kind of model, that is the one-to-one model. See, the one-to-one model maps each user thread to a kernel thread. So that means for every user level thread, you have a kernel level thread. So look at the picture, you can understand that. In the picture you can see there are 4 user level threads which are mapped to 4 kernel level threads. This is called a one-to-one model. Let's go in detail about this model. So it provides more concurrency. So this means this one-to-one model is going to provide more concurrency than many-to-one model, because it allows another thread to run when a thread makes a blocking system call. That means the main advantage of this model is this model is going to allow you to work all the threads in parallel, because each thread is mapped to a single kernel thread. So all the kernel threads, they can be executed parallelly. So that means this model is going to be implemented the parallelism. At the same time, try to visualize that if a user level thread has made a block system call, or a kernel level thread has made a block system call, then what happens? Only that user level thread, only that kernel level thread, they both will be blocked, but remaining all the other user level threads, all the other kernel level threads, they will be executing parallelly on any multiprocessor machine. This is the basic advantage of using such a kind of model. Let's try to understand again what happens here. If a user level thread, or if the small lightweight process or user level thread has made a block system call, then what happens? Only that particular user level thread and that particular kernel level thread which is mapped to that thread, they both are going to be blocked, and remaining all the threads are been running in parallel without any interruption. I think you got my point. Let us try to understand the drawback of this model. See, the only drawback of this model is that creating a user level thread requires creating the corresponding kernel thread. Correct or not? See, creating a user level thread always should be mapped to one kernel level thread. So whenever any user level thread is created, so in turn automatically you have to create the corresponding kernel level thread. This is one of the drawback. So what happens here? Because you can find a overhead of creating kernel threads, correct or not? So whenever user level thread is created, you have to create the kernel level thread. Okay, that's happen. What happens? So increase in number of kernel threads always increases the overload to the performance of the application, and most implementations of this model restricts the number of threads supported by the system. And there are several models which are going to restrict such a kind of model, because you cannot create as many as kernel threads which are equal to the user level threads, because increase in number of kernel threads always decreases the performance of the system. And Linux along with the family of Windows operating system implement the one-to-one model. So what are the models, or what are the operating systems which are going to use such a kind of model? Of course, Linux as well as the Windows operating system. These kind of operating systems, they are going to take the one-to-one model. Then you can put a question, sir, we have a drawback, how they are going to overcome that? Simple. So they have made a constraint that only up to certain level of kernel threads should be created. Beyond that, it should not be created. So they have restricted the number of kernel threads creation. So that is a simple way they overcome with the drawback. So let's try to understand the third kind of the model, that is the many-to-many model. So the many-to-many model, as shown in the figure, it tries to map many user level threads onto many kernel level threads. Correct or not? You can see here. So there are several user level threads. There are several kernel level threads. Okay. What is the special case here? All the several user level threads are being mapped onto several kernel level threads. So that means the many-to-many model multiplexes, you have to use the word multiplex. The many-to-many model multiplexes many user level threads to a smaller or equal number of kernel level threads. So you can also understand that several user level threads are going to be mapped with several kernel threads in such a case that the number of kernel threads might be equal to the number of user level threads. Okay, so if both are same, both are equal number, then it becomes one-to-one, right? If the kernel level threads are less than user level threads, less than to the count of the user level threads, then you can say that it is the many-to-many model, right? So the number of kernel threads may be specific either to a particular application or to particular machine. Then you can put a question, sir, how many number of kernel threads? What is the count of the kernel threads? It depends on the machine or it depends upon the application. So the number of kernel threads or the count of the kernel threads depends upon the application or depends upon the operating system or depends upon the particular hardware components. Let's try to understand the same concept in a single processor machine, in a multiprocessor machine. Simple. If you are having a single processor machine, then your kernel thread might be single. You can have a single kernel thread or you can have a very limited kernel threads. But if you are working on a multiprocessor machine, so it always creates or it always has the ability to create several kernel threads. So that is a simple case. So if you are considering a uniprocessor environment, what happens? Simple. Since you have only one processor, so you have very less number of kernel threads, right? And if you have multiprocessor machine, then you have always the chance of creating more number of kernel threads which are mapped onto the user level threads. So let us try to see the advantages of these models. The many-to-one model allows the developer to create as many user threads as user wants. The true concurrency is not gained because the kernel can schedule only one thread at a time. So this model is going to allow the users to create as many user level threads as he wants. Okay, but still, since you have, since for example you have 100 user level threads and you have 10 processes running in your machine, assume like that. You have 100 user level threads and you have 10 processes running in that machine. So for every processor you have a kernel level thread. So that means maximum you can create, for better performance you can create 10 kernel level threads, right? So all these 100 user level threads are mapped onto these 10 kernel level threads. So what is the maximum performance you can do? So at any instance the user level threads can execute 10 jobs because you have only 10 processes, and at any instance only 10 processes or 10 kernel level threads can be executed. So even though you have 100 user level threads, but only 10 user level threads can be executed, right? So the true concurrency, so you don't assume that all the 100 user level threads are being parallelly going on, because you don't have that much number of the processors. So the true concurrency, the true parallelism is not gained because the kernel can schedule only one thread at a time. The one-to-one model allows greater concurrency, correct or not? Very simple. You have n number of user level threads, you have n number of kernel level threads, simple. So all the user level threads will be executed parallelly. So the one-to-one model always gives the maximum performance, but still that limits to the number of processes according to the machine or the system. Friends, the one-to-one model allows greater concurrency, but the developer has to be very careful because he should not create many threads, or he should not create too many threads within an application, because whenever too many threads have been created, that will limit the performance, correct, right? But the many-to-many model suffers from neither of these shortcomings. That means developers can create as many user threads as necessary, and the corresponding kernel threads can run in parallel on a multiprocessor system. That means in a many-to-many model, so you have n number of processors. At the same time, all the user threads are being switched, are being mapped on many or several kernel threads. So the developer can create as many user threads as necessary, and the corresponding kernel threads can be executed in parallel on any multiprocessor machine. Also, when a thread performs a blocking system call, what happens? When a thread performs a blocking system call, what happens? The kernel can schedule to another thread for execution. This is the major difference between the many-to-many and other models. Let's try to understand again the same statement. What is that? When a thread performs a blocking system call, means when a thread is going to block, or when a thread is going to access a blocking system call, then the kernel thread, or then the kernel, or the operating system itself can schedule to another thread for execution. That means instead of sitting idle, the operating system will immediately switches to another job for execution. So that is the basic advantage of the many-to-many model. And this many-to-many model, it has different variations. Again, this many-to-many model has different variations. If you see the picture, it is a two-level model. If you see the picture, it is a two-level model. It is a variation of many-to-many multithreading. So in the left side, you have 4 user level threads multiplexed on 3 kernel threads. At the same time, in the right hand side, you can see a single user thread is directly mapping to a kernel thread. That means this two-level model can accommodate the many-to-many. At the same time, it can also accommodate the one-to-one mapping also. So this is something called the two-level model. It's a variation in many-to-many model. This kind of model or this kind of variation sometimes normally we refer as two-level model and is supported by the operating systems like IRIX. IRIX is an operating system which is meant for the workstation. That means workstation means a much better performance when compared to a desktop system. So IRIX is a workstation. At the same time, this kind of two-level model can also be supported in HP UX. It is a model, it is an operating system, HP UX and true 64-bit Unix system. So these are some variations of operating systems where they support the two-level model of many-to-many. At the same time, the Solaris operating system supports the two-level model in the versions of older than Solaris 9. So that means Solaris 9 also supports such kind of variation prior to Solaris 9. However, beginning with Solaris 9, the system uses one-to-one model. So these are the questions or these are the important points which you may get in competitive examinations or in the interviews. So Solaris is an operating system which supports the one-to-one model after the Solaris 9 version, and prior to Solaris 9 version, the Solaris operating system is supporting the two-level model of many-to-many multi-threaded model. Let us try to understand the concept called thread libraries. Friends, when we try to write any C program or C++ program or any Java program, normally we try to include the library statements. Like hash include stdio.h or hash include conio.h. So these are the common library statements which we include in our C program. Or if you try to use in C++, we can use the hash include iostream.h. And like that, in a similar fashion, in Java, we used to work with the statement called the import statement. So import java.io.star or java.io.lang.star. So these are some kind of import statements. So such kind of statements, whether it is hash include or whether it is an import statement, such kind of statements always tries to include the library files. Such kind of statements always include the library files. So creating a separate thread for accessing the library. Is called the thread library. So what is meant by thread library? A thread library provides the programmer with an API. API means application programming interface. So a thread library provides the programmer with an API for creating and managing threads. So what do you mean by thread library? A thread library is a predefined library. A thread library is a predefined library in which the user can create and manage the libraries using this kind of thread library. The user can create and manage threads. So thread library is a built-in library module. Thread library is a built-in library module where user can create his own threads and also user can create and manage his own threads. So without the thread library, user cannot create and user cannot manage the threads. So how can we visualize a thread library? So thread library is something like an API, application programming interface. So don't be confused about that. So thread library is a module or it is a package in which using that package or importing that package, a simple user can create a thread or he can work on a thread or he can manage some activity associated with the thread. Now we should put a question: how to implement a thread library? So that means you have a thread library, how you are going to use it. Implementation means simple, how you are going to use it. So you have a thread library, how you are going to implement it. So we have two kinds of implementing a thread library. We have two kinds of implementing a thread library. Of course, there are many ways, but there are two primary ways of implementing a thread library. The first approach is very simple. So the first approach is very simple, in which the thread library is completely been executed or created at the user level, where there is no intervention of the kernel. So in this scenario, or in the first method, or the first way, the thread library is going to be implemented, or the threads which are going to be created using the thread library will always be reside in the user level, such that there is no intervention of the kernel or the operating system. Right. So that means the first approach is to provide a library entirely in the user space with no kernel support. So here all the source code and the data structures for the library exist in the user space itself. Right. So this means that invoking a function in the library results in the local function only. So that means whenever the user program is going to call any function, that function will be executed at the user level, because there is no intervention of the kernel. Correct. And it is not being accessed as a system call. So you can identify this difference here. So whenever a thread has been created at the user level, so whenever any function associated with that thread, okay, that will be executed as a local function but not as a system call. That is a basic point of this method. So when you coming to the second approach is to implement the kernel level library. That means whenever you want to intervene the operating system, then you have to create the kernel level library. Or you need to create the kernel level library supported directly by the operating system. So in this case, what happens? The source code and the data structures for the library exist not in the user space, rather it is in the kernel space. Right. So invoking a function in the API for the library typically results in a system call, because here it is not a local function call, rather here it is a system call, because it is a system call to the kernel, or it is a requirement call for the operating system to intervene the activity. So that means in the thread library, how you are going to implement? We have two ways of implementing. The first way is creating user level threads. Second one is creating kernel level threads. In the user level threads, there is no intervention of the operating system, and every function will be accessed as a form of local function. Whereas in the kernel level thread, the kernel or the operating system has been intervened, has been taken the role for the support, and whenever any call has been accessed, that will be done in the form of a system call to the kernel. Now we must know where are the locations, or where are the options where we are going to implement this kind of thread library. So we have n number of operating systems, correct? We have n number of operating systems, and how we are going to at which operating system which kind of thread library has been accessed. How do we know? Basically, three main thread libraries are used today. The first kind is the POSIX P threads, POSIX, the POSIX P threads. It is a kind 1. And the second kind is the Win32, and the third kind is Java. Right. So what are the three main libraries? The first one is the POSIX P threads, and the second one is Win32, and third one is Java. Friends, if you are a Java programmer, you can directly know that in the Java we are going to use the thread libraries, or we are going to import the thread libraries, and we can directly create and manage the thread, right? And whereas in the Windows environment, whereas in the Windows environment where it is Win32 thread library is a kernel level library. Win32 thread library is a kernel level library available in Windows operating system. That's it, right? Now, what is the third kind or the first kind which you have seen? That is POSIX pthreads, right? POSIX pthreads means pthreads here refers to the POSIX standard. Here POSIX is a standard which is the IEEE 1003.1c. Don't be confused with that. POSIX is a standard for creating the thread libraries, right? So whereas pthreads refers to the POSIX standard and it defines an API for the thread creation and synchronization. Now you can put a question, in which operating system this POSIX standard has been used? Very straight away. So numerous systems implements the pthread specification including Solaris, Linux, Mac or Macintosh operating system and the True64 Unix operating system. So these are the operating systems where they are going to use the pthreads or the POSIX standard, right? And could you please, you can put a question, could you please little bit more detail? Yeah. So in the shareware implementations, in an applications where you have a shared environment, at such kind of environments, the pthreads make a beautiful role, a big role. So shareware implementations are available in public domain for various Windows operating systems, of course, as well also. So what are the three kinds of thread libraries? The first kind is the pthreads of POSIX standard, right? And pthreads are being used in Solaris operating system, Linux operating system, Mac operating system and the True64 Unix operating system. At the same time, the Win32 thread library is going to be accessed as a kernel level library in the Windows systems. And the third kind is the Java library or the Java thread libraries which is used in the Java programming language. So that's all, friends. I hope we are going to finish our session. In the today's session, we have learned about the 3 multi-threading models. At the same time, we have also tried to understand about the thread libraries, how we are going to implement and what are the 3 basic kinds of thread libraries and where they have been used. Hope you understand my session. We'll meet again soon. Bye. Have a nice day.